All right. This is about the third time I've tried this. This is all pretty new to me, trying to do a recording like this, so bear with me. So a lot of people have been mailing me about some confusion about what exactly a function M file is, how you write it, what the hell's going on. So what I'm going to do is I'm going to walk through writing one right here live. So here I am in MATLAB, and I'm going to write a function M file that does something like the following. I want it to find, this is kind of related to one of the projects on one of the questions on the third project. So what this is going to do is it's going to find the maximum, just the maximum, of a quadratic function on a closed interval. Right? So ideally what I would like to do is I would like to, in MATLAB, do something like this. I'd like to create a function and be able to type something like my quad max. I'd like to give it a quadratic function like x squared plus x plus 2. I'd like to give it a say -3 and say 5, and then when I hit enter I would like it to tell me the maximum value of this function on this interval. Right? Now if I try and do this now, it's going to error, right? Because it doesn't have that my quad max function doesn't exist. So we're going to create it. So the first thing we do is we go edit my quad max, notice the same name, .m. And it's going to ask me, do I want to create it? I'm going to say yes. It's going to open a window. Here we go. So in this window I have typed the following. I'm going to type function. I'm going to type r equals. I'll tell you what the r equals in a few minutes. I'll put some. I like to space things out, so there'll be a bunch of spaces, but some of the spaces are not necessary, but they look good. My quad max. And then the function is going to accept 3 things, right? So down here there was a function and an A and a B. So we'll call it F and A and B. And I'll give it some space so I have room to work, and I'll put end. Right? So right now if I save this, over here, save, this function now exists. So if I go down the command, now it doesn't do anything, right, because there's nothing in the middle here. But if I go to the command window and I do, I run my quad max again, now it does nothing, right? But it does an error. Right? It does an error because it found the file, but the file doesn't do anything, right? So now I go to the file, and the important thing to understand is that when I executed this, these 3 pieces of information, this function handle, this A and this B, all come through into this function as F and A and B respectively. So, for example, I could do something like I could do B minus A, right? All it's going to do is subtract B minus A. This has nothing to do with the eventual goal, but this is just to make a point. So now I saved it. If I go down and I run it, again, now it says 8, right? Obviously, because it did B, which is 5, minus a -3. So 5 plus 3 is 8, and it tells me 8. So it did this calculation with the information that came through, right? So now I don't want to do that. So let me erase this, and then we'll start actually writing the function, the real function. So I want to know the quadratic maximum. So there's all kinds of crap going on, right? I've got from A to B, it's quadratic, which means it could have a critical point, it could open up, it could open down. I need to know what's going on. Now, the min-max theorem from calculus says that for a continuous function, like a quadratic, on a closed interval, like AB, that the maximum and the minimum occur either at a critical point, if the critical point is in the interval, or at the endpoint, right? One of the endpoints. So we need to find this stuff, right? So we have to find the critical point. So inside my function, I'm going to say, I'm going to name some of these variables as I feel like. So I'm going to say like crit x, right? This is where the derivative is 0. So I'm going to do a solve diff f. So the diff f takes the derivative of f, right? And the solve solves it, and by default it sets it equal to 0. Right now I have a mistake in here, but I'm going to show you by saving it. So I'm going to save this, I'm going to go into here, and I'm going to run it again. See, it says error, diff is not supported for class function handle, right? So f's a function handle, and I tried to diff it, and it told me to yeah. So let me go in here, and before the crit x, I'm going to put a sims x, and then the f is going to be replaced by f of x. So you did this in the second project. So x is symbolic, so f of x is symbolic. So I can differentiate it and I can solve it. Now, I don't have a semicolon at the end, so it should print the result. And lo and behold, let's go down here, try it again. So look, it said crit x is minus 1/2. So it sent this information through. It did the right thing. It took the derivative of this function, set it equal to 0 and solved, and got negative 1/2, right? Now, so that's my critical x value. So now I'm going to put a semicolon there because I want it to shut up about it. So now I need to know, for example, is the critical point inside the interval, right? If it isn't, I throw it out, right? If it is, I keep it, right? Now what do I have to do? Well, I have to take the critical point, I have to take the a value, I have to take the b value, I have to plug them all into f and see which one's bigger, right? So there are a bunch of different ways that you can do this. So what I'm going to do is I'm going to take one approach, right? You might find a different approach which is faster. This is just the one that occurs to me. Right? So first I'm going to make the maximum. I'll call it maxi because I feel like it, and I'm going to say that maxi is equal to say f of a. Right? Now it might not be f of a, right? I'm just going to assign it, right? So now maxi has a value, right? And then I'm going to say, well, maybe it's bigger at b. So I'm going to say, well, if f of b is bigger than maxi, then maxi now becomes f of b, and end it. Right, so what this does is this looks at f of b, and it compares it to maxi, which was f of a, and if it's bigger, then it makes it maxi. Now, you might not like this. In fact, while we're at this, I'm going to make a change, just so you can sort of see as we go. Right? So you could do something like this. You could say, maxi is 0. Or actually, no, let's do this. Let's do if f of a is greater than f of b, then maxi is f of a. End. And then you could say if f of b is greater than f of a, oops, and I forgot a parentheses, then maxi is f of b. And then there's a possibility that I need semicolons in places. There's a possibility that they're the same. So if f of b equals f of a, maxi is, that could be either one, I don't care, let's say f of b, because they're the same, makes no difference. So now it's looking at just the endpoints, right? If the left-hand endpoint is bigger than the right-hand endpoint, then maxi is the left-hand endpoint, the y value. If the right-hand endpoint is higher, it's the right-hand endpoint y value. And if they're the same, then it's the one on the right, because who cares? Right? Now there's this critical point, right, which might be in the middle. Right? Now, so then we're going to take a look at the critical point. So we need to look at the critical point and see if it's in between. So we go if, and then we'll go if, so my critical point was crit x. So to be between them, crit x has to be greater than a, and crit x has to be less than b. And so this tells me whether crit x is between them. But also I need to know if f of crit x is bigger than maxi, which is the biggest value I've got so far. So let me put a bunch of parentheses around these. Right, so I have parentheses around that comparison. I have parentheses around everybody. And then I go, maxi is f of crit x. End. Right, so let's run through this so we know what this is doing. It makes x symbolic. It makes finds a critical x value, which is where the derivative is 0. It checks f of the left-hand side versus f of the right-hand side. And if the left-hand side is bigger, then the maximum y is the left-hand side. If the right-hand side is bigger, then the maximum y is the right-hand side. If the left and the right are the same, then the maximum y is the right-hand side. Could be f of a, doesn't matter. And then it checks the critical point. It says if the critical point is in the interval, that's what these two things say. And if f of the critical point is bigger than the value that you've got so far, then that value is now replaced by f of critical, right? So now let me semicolon this. So this should do the job, right? Now, of course, if we run this, let's save this, and I go back down here and I run it. It does nothing, right? So that's really boring. Now, the reason it doesn't do anything is because everything's semicolon, and it does all these things, but it just shuts up about them. And what I want to do is I want this function to return the value. So remember this r up here that was sitting here. This r is a variable, and what I need to do is I need to make sure that when all this code ends, that r is assigned to the thing I want to return. Right? It doesn't have to be an r. You could call it, I called it r for fun, but you could call it, say, just in value, for example. And then I'm going to say just in value, and the thing I want to return is maxi. So now it does all this stuff. Maxi is the maximum value. That gets assigned to just in value, and because just in value is this guy, gets returned. So let's save. And let's try it. Ta-da, 32. Right, so let's sort of make sure that we're sane, right? So this is a quadratic function. It's opening up, which means that the minimum is actually the critical point is actually it's a relative min. So the maximum occurs at an endpoint, and if we try the endpoints, right, 5 gives us 25 plus 5 plus 2 is 32. Negative 3 gives us 9 minus 3 is 6 plus 2 is 8. So the maximum is at the right endpoint, value of 32. If we make it opening down, it might change. Now what opens down? 9/4. Right? So that's the maximum there. So again, just sort of let's run through this so we understand what's going on. We've got just in value is just a variable, could be whatever. Got the name of the function. The myQuadMax has to match the myQuadMax. They have to be the same. The three things here are the three things that are going to get passed to the function. So in here we assign a symbolic variable so that we can take the derivative of the function so that we can set it equal to 0 and solve. Crit x then becomes the critical value, like the critical point, the x value of the critical point. Then we check f of the left with f of the right. If it's bigger, then the maximum is, for the moment, is f of a. Right? It might change, right? Something to keep in mind is this is sort of like a work in progress as it goes through. So if the left-hand side is higher than the right-hand side, then maxi is f of the left-hand side. If the right-hand side is bigger than the left-hand side, then maxi is f of the right-hand side. If they're the same, then it's either one. So at this point, at this end, right here, in this space, when it gets to here, maxi is just the higher of the two endpoints. Then it needs to check the critical point. So it takes the critical point, it takes the x value, checks if it's bigger than a and less than b. That checks if it's in the interval. So both of those have to be true. And also, f of that critical x value must be bigger than the maximum that you found so far. And if it is, then the maximum that you had found so far is replaced by f of the critical value. Then it ends. I assign just in value this guy to be maxi because that's what I want to send back, and I end. So that gets sent back. It gets printed here because it's sent back. So this code is by no means optimum, right? All this crap could probably be done in about 3 lines, but I did it slowly to sort of hopefully make sense of it as you read through it. So good luck.